Yeah, so I'm going to be talking to you a little bit about Axial 3D and our journey through the years and how AWS has supported us through each of the kind of transitional life cycles of the company. So to give you a little bit of background on the company, what we do is we make 3D printing in medicine routine. So the rationale for this is because if you think about it, you've got CT and MRI scans. You're looking at hundreds of complex two-dimensional images, but to get a better conceptualization of those images, we make them into physical models. And they've been proven to make surgeries faster for surgeons, cheaper for hospitals, but most importantly, safer for patients. And what this practically means is taking these complex two-dimensional pixel images and converting them into physical one-to-one scale portions of anatomy. And I wanted to start off by giving you a little bit of context on why medical 3D printing is so important. So this is Jonah. Jonah's a 14-year-old kid based in Belfast. Jonah has congenital scoliosis and has had 3 operations in total in his lifetime. So Jonah was admitted to the Royal Victoria Hospital in Belfast about 12 months ago, needing an additional operation on his spine to improve the curvature. So his surgeon, Mr. O'Brien, approached us with these 900 two-dimensional images, and he was basically scratching his head and he didn't know what he was going to do. So we were able to take these 900 two-dimensional images and make them into a physical representation of Jonah's anatomy. And this allowed Mr. O'Brien to get a much better conceptual understanding of the patient's pathology, and it allowed him to actually see where the Vespar rods, so the white rods running up and down Jonah's spine, were in relation to the 100 different portions of anatomy that he needed to conceptualize. So one of the things that Mr. O'Brien was able to actually see that he wasn't able to find on the two-dimensional images were the rods that were actually anchoring on Jonah's pelvis, the rods here, had actually fractured through the iliac crest. And this meant that Jonah would have had to have gone in for an extra surgery because he would have found this out on the table. So because we were able to give Mr. O'Brien and Jonah this model, we were able to reduce 3 hours of surgery and also reduce the readmittance of Jonah into the Royal Victoria Hospital. So for those of you who don't know, 3D printing's been around since around 1984, and in medicine, it's actually been around since 1991. But there's a few things that are stopping medical models being used routinely in medicine. So the first thing was access to medical images, so getting access to DICOMs and also access to the prescription of what surgeons need can take a lot of time and a lot of effort. So to put it into perspective, when the company was founded, around 5 years ago, we were purely a service-based company. And to actually make our first model, it took around 6 weeks of time. So we had to go into the hospital, we had to get CDs burnt to get medical images, and we also had to liaise with the surgeon back and forth to get the prescription of exactly what they wanted. So that wasn't applicable for scale. And what we were able to do was actually create a web application, which is hosted on AWS, to allow surgeons anywhere in the world to upload their DICOM images, convert those DICOM images into a 3D visualization on the cloud, and enable the surgeon to tell us exactly what portion of anatomy that they want to print it in, and what color and size and shape. So this web application, which is hosted on AWS, allowed us to take a process that took 4 to 6 weeks and cut it down to about 48 hours. So this allowed us to scale within our local markets, primarily within the NHS, and allow surgeons all across the NHS to actually gain access to 3D printing. But one of the cases that came around about 2 years ago that I want to go through in a bit more detail is kind of the rationale for the company transitioning into artificial intelligence and machine learning. So this is Catty. Catty is a 22-year-old mother based in Belfast, and she's had renal failure all her life. She had a previous kidney transplant, and she was in renal failure again. So one of the issues, because she'd already had a renal transplant, she was on immunosuppressants, so it meant her donor pool was extremely light. So basically, the only people who could actually give her a kidney were immediate family members. But luckily for her, her dad William was a perfect match. But one of the things that William's surgeon found pretty quickly into the scan, so they'll get a series of CTs and MRIs to evaluate the size and shape of the kidney so that they can see if it's a match for the patient. But what they found was a little cyst on William's kidney, which turned out to be a thing called a Bosniak 2 cyst, so a cancerous tumor in William's kidney. So this represented a huge problem because effectively Catty only had one kidney in the world that she had access, that she could get transplanted, and it had a tumor in it. And from looking at the traditional two-dimensional images, the surgeon actually thought that it wasn't transplantable. They couldn't save enough of the kidney or dissect enough of the tumor away to actually reimplant into Catty. But what we were able to do was give Mr. Brown, the surgeon, access to the web application. We were able to take that data and process it in-house and 3D print an exact replica of William's kidney. And this is it here. So this allowed the surgeon to get a much better conceptual understanding of the actual tumor, along with the ureter and the two vital blood vessels that were supplying the kidney. And from just seeing this, he was instantly able to know whether or not he was going to be able to transplant the kidney. And luckily for Catty, there was enough of a margin between the renal vessels and the tumor itself to actually dissect. So one of the things that the surgeon was actually able to do was sterilize the model and bring it into surgery with them, so that they could actually cut out the tumor in situ. So luckily, they were able to use the model on the back bench in surgery, cut out perfect margins across the Bosniak 2 cyst, and actually sew the kidney back up. So within 48 hours of the kidney being retransplanted into Catty, she had normal renal function. And because the surgeon was able to conceptualize and understand the exact location of where the tumor was within the kidney, they were able to get perfect margins. So this was the first time this was ever done in the world. It was done previously in Canada, but it wasn't. They basically had to resect the tumor and then go in a second time to resect more of it because the margins weren't good enough. So we kind of, as a company, we took a step back and we were thinking, that we'd kind of solve the issue of getting access to data and enabling surgeons to upload DICOMs and give us prescriptions. But there was a huge thing that was stopping the worldwide adoption of 3D printing. And it's a process called segmentation. So you'll see it all around the booths here today. But what I talk about when you're talking about segmentation is basically the process of annotating two-dimensional medical images, so CT and MRIs, to create an STL file, so a file that's specific for 3D printing. And to put it into perspective, so the case, Jonah's spine case, takes around 4 or 5 hours to actually process that data manually. And if you extrapolate that up, it's on average about 3 hours to create every case, or it was when we were a service-based company. And to put it into perspective, there are around 3 million cases that are applicable for 3D printing, which is about 2% of the world's surgery. It would take 3,000 man years of actual labor to address the market. So that's something that we need to step in and fix. And how we do that is by using machine learning. So by using SageMaker, we've collected hundreds of thousands of pre-labeled data sets that our engineers have made and started utilizing those to actually automatically segment and create these STL files from these medical images. And what we're also able to do is we're able to house all of our medical data on the AWS cloud safely and securely. So through data collaborations, we have over 3 million two-dimensional medical images that we can now utilize to actually segment and automate the process of 3D printing. So to show you what this looks like, this is an example pretty similar to Jonah's that we got about 6 months ago. So congenital scoliosis of a 6-year-old patient. And what you're seeing here is the automated labels that are created from the convolutional neural network that was created. This is automatically segmented in minutes as opposed to hours. and this is the resultant 3D model. So this enables us to effectively address the market in orthopedics. So what we're doing now is we're aggressively developing out our cardiology, neurology, and oncology data sets so that we can automate the exact same process in all other specialties. I'm kind of taking a step back to sort of the reason we do what we do are these numbers. So since the company started, we've effectively improved hundreds of pediatric cases, saved thousands of hours of surgery time, and saved 3 lives in the last 4 years. And that's with mainly manual processes. So once we automate the process of segmentation and enable every surgeon everywhere in the world to gain access to 3D printing, these numbers will go through the roof. Thank you. Does anybody have any questions?